Gewi was founded in 1992 by Hagen Geppert and Dr. Carl Will. The Gewi name is derived from the first two letters of the two founders' last names. Gewi began as a specialist developer of programmable hardware for global television manufacturers, with customers such as Sony and Grundig. In 1997, Gewi produced one of the world's first FM receivers to collect RDS-TMC data to display on video monitors at airports. With the ability to inform travelers, Gewi's customer identified a new requirement: to be able to display more traffic information than was available. One of the problems at the time was lack of sources of accurate digitized traffic information. Gewi analyzed customer requirements and offered to develop software that would collect, view, create, store, and distribute traffic information to the RDS-TMC receivers. This became Gewi's first generation of the TIC product, named TMC Office. Gewi Business. The company consists of three corporations: Gewi Europe based in Germany, Gewi North America based in Texas, and Gewi Asia Pacific based in Singapore, with additional offices in the UK and USA. Gewi has a global customer base and has been ISO 9001 certified for quality standards annually since 1997, and is currently certified ISO 90012008. TIC product. After its first generation of traffic data products, known as TMC Office, the company renamed the product to TIC Traffic Information Center. TIC is a fully commercial off-the-shelf product COTS that customers can use to avoid problems associated with custom builds. Today, TIC is in its fourth generation and is used for a wide range of projects including traffic and travel information services can include meteorological weather information, RDS-TMC, TPEG over HTTP or digital broadcasts such as DAB, navigation system testing used by many device and car manufacturers, traffic news for radio, structured news reports auto-generated as ready by announcers, data harmonization and exchange, parking information, work zones such as road construction, radio data using PAD program, associated data with station names, schedules, and music titles, and connected vehicles. Markets. The TIC software is used by customers in commercial and government markets for a variety of traffic and travel-related projects including traffic and travel information services. TIC can be used to collect and create a wide variety of data including traffic incidents, travel events, weather conditions, parking availability and pricing, and many more. TIC allows data to be manually created by operators entering information using an easy-to-use dialog with drop-down lists, maps, and quick auto-completion. Data can be created using the TIC client application on computers, iPad, or over Internet connections. Data can also be automatically created from other data, for example traffic and travel event data from traffic flow data. Road Incident Management. In 2015, Gewi added Road Incident Management RIM to the TIC product features. The TIC product feature Road Incident Management provides a method to integrate this information and allow agencies to manage road incidents as well as traffic incidents, and to keep the public informed with accurate and updated traffic and travel information. The TIC product feature Road Incident Management provides a method to integrate this information and allow agencies to manage road incidents as well as traffic incidents, and to keep the public informed with accurate and updated traffic and travel information. TIC can be used to define and track pre-agreed incident response plans, providing operators with a step-by-step process to properly respond to traffic and roadway issues. By using TIC to track the response, each action is recorded, allowing for a full review of the implementation and timing of the response, in order to measure how well the incident was handled, and whether any improvements to the response could be made. If the incident involves roadway infrastructure, such as road sensors or VMS signs, the status of each can be recorded as well, down to and including road surface conditions from weather sensors, to better understand how an incident developed and, on review, what could be done to prevent a reoccurrence. TIC can be used to help support agency services such as ADAS Advanced Transport Information Systems, and eCall, a European initiative being launched in 2018 for new vehicles. A RIM video produced by Gewi which provides further details is available. Real-time information for navigation. TIC can be used to collect and create traffic and travel messages that can be broadcast as traffic message channel TMC messages with or without encryption over FM using the radio data channel RDS, or distributed over the Internet using connected services. TIC can regionalize and prioritize TMC messages, and can also be connected to RDS encoders at FM transmitter sites using the standard protocol UACP, as well as to FM receivers for RDS-TMC service monitoring. Additionally, many car and navigation device manufacturers are able to provide more than just traffic and travel event information. They may also provide information about traffic flow, such as traffic speed, weather, and parking. This enhanced information is provided using PEG, either broadcast, or for an interactive driver experience with connected vehicle services, by using internet connections. TIC can be used to collect and create traffic and travel event data, as well as collect traffic flow data such as speed and volume, all referenced to a harmonized road network. Traffic and travel event data can be automatically created from traffic flow data. TIC can create as well as distribute standard PEG-TEC traffic event compact and PEG-TFP traffic flow and prediction, referenced either to TMC locations or the standard Agora-C and OpenLR referencing methods used to dynamically encode and decode locations without using a fixed TMC location table. The PEG messages can be distributed as either binary, over THTTP, as digital radio broadcasts such as DAB and HD, or in PEGML to exchanged PEG data with other service providers or systems. Navigation system testing. Car and navigation manufacturers must test their navigation devices to ensure their devices will work consistently at different locations with different data from traffic information service providers and in order to avoid creating a new device for each market. For RDS-TMC, TIC can be used in a test environment to broadcast traffic data samples provided by traffic information service providers, or manually created traffic event data, to RDS encoders connected to FM transmitters. TIC can also be used in a real FM broadcast environment to collect data and test broadcast quality. For PEG, TIC can be used to manually create traffic event and flow data, and to automatically convert this data into PEG-TEC and PEG-TFP messages which can then be distributed over Internet HTTP using the standard THTTP request and response protocol. In addition to PEG binary, the XML representation can also be distributed over many different protocols, such as DAB or FTP. Traffic news for radio. The TIC software can be used to create news reports which can be published for use by stations, broadcasters, and agencies. Data can be distributed to websites, smartphones apps, and other mobile device services. Standard data exchange formats are supported including IPTC and NewsML XML. Data can be compared and merged to reduce duplication and can be organized to increase relevance to the radio audience. Producers can then use TIC to create news stories by selecting, grouping, and prioritizing traffic and travel events into a traffic news report. When different reporting styles and languages are required, these can be quickly and easily created. Announcers can then read the traffic news on air either using the station's own system or by using TIC's own newsreader feature to adjust time and scroll the news report. Workzone. TIC can be used both to collect and create workzone information using a TIC client application on a mobile device or computer, or even from other systems and devices. Captured or entered data can include a harmonized location reference, work type, status, times, and lane information such as restrictions, closures, and capacities. Road conditions and restrictions can be manually entered by operators from reports or automatically collected using other systems. Each project can be reported as a whole, or in phases, depending on the requirements of the project. The work zone projects can be scheduled in TIC, and can provide information on a consistent or recurrent basis as needed. Radio data. Radio stations can improve the listener experience by providing information which can be shown on displays built into radio receivers. The information is known as program-associated data pad. Pad information can include the station and program name, song title and artist, and program schedules. TIC can be used to collect and create pad information and to then adjust the timing of pad information to match the content actually broadcast. TIC can regionalize pad to the actual broadcast coverage by centrally managing the pad data, thereby providing consistency across all broadcast media types, including FM radio data system RDS and digital audio broadcast DAB transmitters, satellite, and Internet. Data to FM RDS encoders can include radio text RT, alternative frequencies AF, and traffic message channel TMC. Data to DAB inserters can include dynamic label service DLS, PEG applications, broadcast websites, electronic program guide EPG using radio schedules collected from an existing system, and slideshow such as traffic images from roadside cameras, logos, or advertisements. Its asset management. Government transport agencies worldwide manage and maintain many types of intelligent transport system. Its assets including cameras, traffic lights, ramp meters, VMS signs, road sensors and keep road users informed about the impact on traffic and travel. Agencies spend a lot of effort maintaining and repairing its assets, which can be difficult when assets and project information are kept in several different places. TIC helps to reduce effort, time, and frustration by consistently managing assets all in one system.